Okay, so today we're going to be talking about evaluating inverse trig functions. Before we've talked about the regular trig functions with sine, cosine, tangent, secant, cosecant, cotangent. With inverses, if you remember from previously when we've talked about inverses, we talk about if they're one-to-one. So to check that, you have to use the horizontal line test. So first thing we're going to look at is our original equations, their inverses, and the reason for them to occur. Okay, so we're going to be talking about sine, cosine, and tangent. Okay, the reason for just these three is the other three are not that common, so we're not going to deal with that right now. The inverse can be written as arcsine or sine inverse. Those are interchangeable. They mean the same thing. The reason for this is y equals arc sine x is true if sine y equals x. So what this is saying is that the inverse of an angle is equal to y. Okay, and we flip that. That means that at that y we have our angle. So we're looking at the angles today. So the arc cosine, oh I forgot a c, is also the inverse, so those are interchangeable. So same thing for this. And finally, tangent, arctan, and tan inverse. Remember, these are the same thing. Okay, so now we're going to look at the domains for these values. Because of the trying to get an inverse and stuff, we have to restrict their domains so that it will be true. Okay, so with arcsine, so the inverse of sine, our domain is from -1 to 1. Okay, our range is from -pi/2 to pi/2. So that means if we look at our unit circle here, we're just using this right half of the circle for our range, because our y values, this would be -pi/2, this would be pi/2. Okay. Then we have cosine. Our domain is from -1 to 1, and our range is from 0 to pi. Okay, so that would be the top half of the unit circle because we go from 0 to pi. Okay, and if we look at our y values, so our domain, we have anything from 1 to -1 or -1 to 1. Okay, and lastly, we have arctangent of x, so the inverse of tangent. And our domain for this is from -infinity to infinity. I don't know why I put a comma there. Ignore that. And our range is from -pi/2 to pi/2. Okay, and if you remember, that was where our asymptotes were. So for this, again, we're going to be looking at just the right half of the unit circle. Okay, so that gives us our domain values, domain and range. Okay, then we're going to be using the unit circle to evaluate these things. So example 1, I have arcsine at -1/2. So the question I want to ask is, where between -pi/2 and pi/2 is y equal to -1/2? Because remember, sine is y. So I'm going to take this unit circle and I'm going to look at just the right half of the circle, and where is my y value, -1/2? Okay, well if I look, my y value is -1/2 here at 11 pi/6. But 11 pi/6 doesn't fall within that range. So what is the negative value of that? Okay, if we look at that, it's going to be -pi/6. So your answer would be -pi/6. Okay, example 2, we have the arc cosine of √2/2. Okay, this needs to be in the top half of the circle. So where in between 0 and pi is cosine? So our x value is √2/2. If we look, our x value is √2/2 here at pi/4. Okay, so there's that. We keep going through these examples. Example 3, where's tangent? -1. And if you remember, tangent is y divided by x. So again, we're looking at the right half of the circle for tangent. Okay, and that means that my x and y value need to be the same, but one's negative because it ends up being -1. So we look, that's going to be at 7 pi over 4, but because it has to be in between negative pi over 2 and pi over 2, that's negative pi over 4. Okay, next example, where is the inverse cosine -1? Okay, so cosine, look at the top half of the circle. Where's your x value? -1. If we look, it's -1 at pi. So your answer is going to be pi. Example 5, inverse sine, square root of 3 over 2. Okay, remember sines, your y values, we're looking at the right half of the circle. If we look at that, we find out it's at pi over 3. Example 6, this is the last example of this kind. Arctangent at 1. So remember, tangent's y over x, so we're looking at just our x's and our y values. Okay, they need to be the same if it's going to be 1. So where are they the same? If we look, they're the same at pi over 4. Okay, so there's that. You're using your unit circle. And I would suggest using this sheet of paper that I got laminated for y'all so that it's easier for you to access. Okay, the last thing is we have some properties. Okay, the first property is that if we have arcsine, so that's our inverse, times sine, the original, this is going to equal whatever this y is, whatever this angle is. Okay, so same for each of them. So arc cosine times cosine y is going to equal y. Arc tan tangent y is going to equal y. Okay, and it would go if we had it flip-flop the other way. So if I had sine times arc sine, it would equal that. So if we look at some of those examples, if I had tangent times arc tangent of -5, this is going to equal -5. Okay, so again, this is the opposite of this, but it holds true the same way. Okay, so cosine times cosine inverse, pi, these counteract, so your answer is pi. Okay, so that's what we have for our lesson today. This is your first assignment for the 5th 6 weeks. It is page 349, number 2 through 8 even, and 43 through 48. Good luck, and let me know if you have any questions.